Hi, my name's Leah Vestal.
And I'm Kirsten Courtney.
Today, Kirsten and I are going to discuss the function as well as the components of an X-ray tube. The X-ray tube is an important part in X-ray production.
The function of an X-ray tube is energy conversion. The tube acts as a vacuum tube where electrical energy is converted into X radiation and heat. The heat is an undesirable byproduct. X-ray tubes are designed and constructed to maximize X-ray production and to dissipate heat as rapidly as possible. The basic internal components consist of an anode and a cathode.
X-ray tubes are designed in a certain way to lower the amount of heat produced. This can be accomplished by the rotating of the anode, which gives off heat. The X-ray tube is designed with the anode attached to a rotor and the cathode on the other side of the anode. This design determines the characteristics of the X-ray beam. A normal cathode is made up of a negatively charged small coil of wire called the filament, which is shown here, which is housed in a focusing cup, which is shown here in blue, and then the filament is in pink. The filament is a negatively charged coil of wire, which becomes heated when the electrical current passes through, and when that energy becomes enough to expel the electrons from the filament, it's called thermionic emission. The function of the cathode, shown here, is to push out electrons, which are produced by the electrical circuit, and to turn those electrons into a beam, which the beam is aimed at the anode. The filament is contained in the cathode is usually designed using a material known as thiorated tungsten. This thiorated tungsten allows for a higher temperature without the filament melting. And there are different sizes of filaments which can help to vary the spatial resolution according to what is being X-rayed.
The anode is the part of the X-ray tube where X radiation is produced. It is a large piece of metal that connects to the positive side of the electrical current. Here in our diagram, we have it shown in red right here. The anode provides a mechanical support for the target. The material of the anode enhances the conversion of energy and aids with heat dissipation. Most X-ray tube anodes are a tungsten alloy, which has an atomic number of 74, and this improves for the long-term radiation output of tubes. Tungsten is unique in its ability to maintain its strength at high temperatures, and it has a high melting point and a relatively low rate of evaporation. With X-ray tubes with pure tungsten anodes, the radiation output is reduced with usage because of the thermal damage to the surface. There are two types of anodes, stationary and rotating. In this diagram, we have a rotating anode, and its sections will be discussed later on. But stationary anodes are primarily used in dental X-ray systems and some portable units. High tube current and power are not required for stationary anodes. Rotating anodes, however, have the capability of producing higher energy X-rays with shorter exposure times. They have more target surface area and more heat dissipation. The target area is the part of the anode where electrons from the cathode strike. It is made of tungsten.
Now we are discussing the focal spot. Not all of the anode is involved in X-ray production. The radiation is produced in a very small spot on the surface of the anode, which is known as the focal spot, or also known as the target. The dimensions of the focal spot are determined by the dimensions of the electron beam, which will arrive from the cathode. Focal spot dimensions typically range from 0.1 millimeters to 2 millimeters. The X-ray tubes are designed to have specific focal spot sizes. A small focal spot can produce less blurring and better visibility of detail, and a large focal spot will have a greater heat dissipating capacity. Focal spot size must be considered for specific applications. Small focal spots are used for small and thin body regions, and the amount of radiation needed is relatively low, whereas large focal spots are ideal for imaging the lumbar spine. Most X-ray tubes have two focal spot sizes, small and large, which can be chosen by the operator.
The X-ray tube housing provides several functions in addition to enclosing and supporting the other tube components. Here we have the X-ray tube enclosure in bolded black, and this steel enclosure is lined with lead and acts as a shield to absorb leakage radiation that isn't a part of the useful X-ray beam, and this also prevents electrical shock. It also dissipates most of the heat created within the tube. There are two other components, one inside the tube and the other outside. The stator is the part outside of the enclosure, which is shown here in green. And it consists of a series of electromagnets equally spaced around the neck of the tube. And the rotor is the part inside the tube enclosure, consisting of a copper and iron shaft. And it's shown here in a teal. These two components create an electromagnetic induction motor that's responsible for rotating the anode.
As Kirsten mentioned previously, the enclosure absorbs leakage radiation. What is leakage radiation? It is X-rays that escape through the protective housing. This can be reduced through shielding the unit housing sufficiently, as well as shielding the operator of the unit and the patient, and measuring exposure near the unit. All in all, this concludes our presentation on X-ray components. Thank you for watching.
I would also like to give major props to our director, cameraman, Jackson the Cat.